Welcome to our second screencast on GUI programming. Today we're going to talk a little bit more about events and how to manage events. So remember that GUIs generate events and they're event driven, they're not polling. So the general idea about GUI programs is that while the program is still running, you wait for the next event to occur. So whenever the user does something, presses a button, moves the mouse, or or types in something, that generates an event, and then the subroutine that handles the event, the registered hand, deals with the event as they occur. So this is called the event loop. And remember that the subroutine that handles the event is often called, or in Java is called, the listener. So we listen for events, and when they occur, the listener deals with the events and does whatever they need to do to deal with the event, and then we continue on. So you also notice that the program, you could close the last window and your program is still running, waiting for events that are not going to occur because you don't have any GUI components left available, but the program is still running in the background, and often you need to hit the little stop button or hit Control-C if you're using the console to actually quit the program, even though all the GUI components are gone. The program is still in that loop waiting for events to occur, and the events aren't going to occur because the GUI's gone. So that's just something to think about when you're programming with GUIs. So let's talk about mouse events. Java has a mouse event class which encompasses the mouse events. So when you move the mouse, or when you press the mouse button, or when you release the mouse button, there's a lot of different events that are generated. They're all mouse events. The class is the Java AWT, so that's the older style GUI stuff. Remember, there's Java X Swing, which is a newer component. The mouse event is in the Java AWT event package. And there's also a MouseListener interface that's defined that you can implement so that you can handle all the different kinds of mouse events that Java supports. So there's mouse clicked, so when they click the mouse, entered, so when the mouse enters the component, so you move the mouse over a button, you get a mouse entered event. Mouse exited, so when the mouse leaves that component, you get an exited event. A pressed, which is the pushing the button down, and released. Clicked is up and down. Pressed is just the down, and mouse released. So you get very fine-grained interface on how to know when mouse things occur over your particular GUI component. And also remember, you have to implement your listener that handles the events, but you also have to register your listener to the component so that that listener will get the events for that component. And you use that with the MouseListener, and you pass in an implementation of the MouseListener interface. So how would we implement a MouseListener? Here's an example of a repaint on click. So we implement the MouseListener interface. We have to implement all the 5 of the methods. So we're doing the mouse pressed. We grab the component because the event has a getSource method that tells you what the source, the component of the source of the event is. So that gives you the actual GUI component. We have to cast that to a component, and then we can call the repaint method, which causes the component to repaint, or request to be repainted, and that will eventually call the paint component with the graphics command or graphics instance, and then you can repaint yourself when the mouse is pressed. So this will refresh the screen or the component whenever you press the mouse. We have to implement the other 4 methods, but we'd have empty bodies, so we're not actually handling a mouse clicked, entered, exit, or released. We're just handling on the press, which is up and down. So you can imagine putting in a whole set of different behaviors. Maybe on a mouse entered, you want to do something, maybe highlight the component, or mouse exited, maybe unhighlight the component, something like that. Same thing with mouse clicked. So when they press it down, when they go up and down, we do something different than when they just press the mouse button. The MouseEvent Data has several components to it. One, you can get the X, Y position in your component. Remember, all components have a X and Y, the 0s in the upper left-hand corner. X grows larger to the right, Y grows larger down. So you can get where the mouse event was occurred. So maybe when you get a click, you know where it was clicked, or where the mouse entered your component, you can get X and Y, or where it left your component. You can also they have the concept of modifier keys. So like if Shift click, Control click, Alt click, and then Meta click, those are potential key bindings that if you hold the Shift button down and click, you'll get the event is Shift click down is true. Also, Java has a concept of 3 buttons on their mouse. Not all mice have 3 buttons. Classic Mac has only 1 button, but you can get the button that was pressed when the mouse event was generated. Some mouse events are not generated with a button, so entered, there is no button associated when you enter or exit, so that getting the button would say no button because it was not generated by a button. You also can check that even if a mouse doesn't have 3 buttons, some of the other meta things or control might be set. So you might be able to get around, if there's a gesture on the mouse that is equivalent to a right mouse button, that might be a way to get which button was pressed. So there's a lot of ways that once you're in your handler, you can get information about the mouse event that might help you do things like draw on the screen or whatever. There's also a MouseMotionListener that allows you to detect when the mouse is dragged and moved. Notice it's in the past tense, so you need to if you're going to do drags and things, you need to remember things by attaching the mouse pressed thing to say, I'm going to remember where the drag started, because the mouse dragged is going to run or be executed when the drag event ends. So you would say, I want to remember where we started, and then where we ended my event, my listener will execute. So it's a 2-step process. Remember where it started, and then where it ended. So it is a little bit more complicated, but you do get an indication of when the drag event ended or when the mouse stopped moving. You don't get an indication when the mouse started moving, but often that might be on an enter or a press. There are also anonymous event handlers. We talked about this last time. It's often it was done a lot in Java programming because you actually just implement the things that you need for the thing. There's a mouse adapter class in Java that actually implements all the listeners for the mouse. It's an abstract class, so you actually have to over or extend it, or in our case, we're making an anonymous event handler by saying new mouse adapter. So we're going to take an instantiation of the mouse adapter, which is abstract, but we're going to supply the method or methods that we want to overload or override on the mouse adapter class. And by supplying the actual implementations, that gives us a new anonymous event handler. So here you can see how you're focusing on what do I want my event handler to do in this specific instance. So for example, if I'm doing the repaint, I only need to do the mouse pressed because it's an anonymous event handler. I can add it and I've got all the work done right here. It's a nice way of doing it without having to write your own extension to the mouse adapter class. Writing a new class, you can do it all sort of inline, and it's a very nice way of focusing on the problem and solving the problem. The next thing to talk about beyond mouse events is the idea of timers. Java Xswing Timer is a class that generates action events after a specific amount of time. So you can set up the timer class to generate an action event every so many milliseconds, and it will keep generating them, or it can wait some milliseconds, generate one event, and stop. It works with action listeners, which are similar to like button presses. Button presses generate action events. The action listener interface has one method, action performed. It takes an action event. So we can create a timer, hook up the timer to a listener, and then have that listener execute periodically based upon the timer. To construct a timer, you just create a new timer. You supply the delay. How long are we going to wait until we fire the first event, and how long are we going to wait between events? And we supply the listener that's going to handle these events. That doesn't actually start the timer. You then later on have to say exactly when you want to start the timer. The timer will then wait that many milliseconds, fire the event, and continue firing the events. There are other constructors for the timer class that provide different, you can say zero delay and what's the period, etc. So this is one helpful constructor for the timers. It's a nice way of doing animation because you can have a timer that goes off, let's say 30 frames a second, and redraws the frame. So we want that to happen every 30th of a second. We can set up our timer that will cause the repaint of our scene, and that's how we would simply do animation. And we don't have to worry about the frame rate because the timer will handle the repaints. So it's a very nice way to do animation. And actually, it's a nice way to do things like, oh, wait 5 minutes, and then something, if for a quiz or something, you can have a timer kick off when the quiz is over or something like that. Very nice class. The next kind of event is a keyboard event. They generate key events. There's a key listener for pressed, released, and key typed. That's similar to the mouse. Pressed is down, released is up, typed is down and up. Key events are not generated if the component does not have focus. The idea of focus is that if you're doing a multiform thing, which input box is got the focus, so you can change the focus over the components in your GUI, and we can have a focus listener that gets the events when the focus is gained or lost. That's a good way of, if they're tabbing out of a text box or something and you get the focus lost, you then might want to validate the contents of that text box to make sure that they typed in a number and not a letter or something like that. So that's a nice way of making your GUI interactive and validating their data if you're doing a sort of a form kind of GUI. So the idea is the key event has a representation of the different possible or many possible key values. So you can say what key was pressed, the A key or the 6th key. So there's a lot of ways that the key event allows you to get information about which key was pressed. That's often useful for doing simple graphical games. If you want to move the character left, you move the character right. You listen for the key events and then decide based upon which key was pressed what action you want to do. And so that's my very quick, see my code? That's my very quick discussion about events. We're basically doing, remember, it's the event loop. The GUI program starts the program and is in an infinite loop waiting for events. When the event occurs and it's been registered to a listener, we then call that listener's subroutine, and that handles the event, and then we go back and we wait for the next event. So that's my quick screencast. Thank you very much for your attention.